In this video podcast or video, we will focus on the collection of server component information for a DevOps administrator. The previous video, we focused on PodView and how we registered liquid cooled servers, specifically a Blackwell Compute, and how it gets registered within PodView. Uh, Also, registration association with PDUs and also CDUs, or an in-rack CDU that's associated with a rack. So next is we're going to navigate to the compute list. And the compute list is really the hallmark of SuperCloud Composer. It is the module that focuses on day 0 through day 2 server lifecycle management. And on the top here, you can see all the buttons that are associated with a task that a server architect would perform in their data center. Power management, BMC unit reset, tag management, deploying an operating system, turning on the UID, array systems such as simplified storage, performing firmware updates, BIOS and BMC, connecting into the IKVM, and potentially data server forecasting, such as collecting or data mining appropriate metadata to make those data-driven decisions, which can be in a CSV format, JSON format, or YAML. So we talked about this in a previous video set or podcast on data mining. If you're interested in that, I would encourage you to go look at that particular video where we take essentially metadata or attributes from a server, gets created into a CSV file, gets exported out, and then we take that CSV file and import it into pivot tables and make fancy charts and also graphs. So, so that's a little bit off of what we're really going to focus on today is really the Blackwell compute and how we can actually perform lifecycle management on that server. So is it any different than any other server? No, not at all. It's whether you're going to manage H100 or G200 servers, whether you're going to manage a blade. They could be liquid cooled servers, they could be air cooled servers. Of course, it could be a Mega DC family, which is supporting Ampere, all our golden SKUs, which are Ultra family, Blade family, GPU family, Big Twin, and Hyper DC Cloud. All of those would be nowhere different in how we would manage and monitor them. So let's look at that particular server, which is the Blackwell. And it, if you recall, is 172.24.169.23. And let's take a look at it from a high level look. If you see here, if you remember, the product SKU was SYS 422GA NBRT-LCC. LCC is the nomenclature for a liquid cooled server, and we're using a motherboard type of X14. So the SYS is a designation that it is a Intel-based platform. Anything that starts with a nomenclature of AS is a AMD platform. So by learning the different nomenclatures for SKUs, you can easily identify if it is an Intel-based CPU or a AMD-based CPU. So you could see here the location. As you recall, we were in building 6 liquid production. We identify that where that is in the rack. You see here on the left-hand side a breakdown of that liquid cooled server, which is in building 6. So we have association and a hierarchy approach to rack slot units, things of that in our compute list. You can see here the green icon represents health okay. You see here that the node has been composed, an operating system has been deployed on that particular server, and the health is okay. And you can see here within the actual front and rear view a look and feel of that server. So if you look on the top here, you'll see here on the front view those two connections where basically the return and also the input source gets connected into this particular server. It passes across the cold plate, which is a combination of glycol and water, passes across from the CDU and passes across that cold plate. And when the server gets ramped up on workloads, the CPU and GPU basically heat, and so that's a mechanism to basically cool that so that you don't overpower or create an over temperature condition on that server. It's there to protect your capital investment. So looking at the physical assets information here, we see chassis part number, we see serial number, we see the product SKU, the product serial number here, and then the manufacturer, the drawer height is a 4U. Remember the air-cooled GPU server for Blackwell is 10U. This one we're looking at is a 4U, which is liquid cooled. And then you see here that it's part of the GPU family. We break our servers down within SuperCloud Composer based on product families for easily able to identify and group together so that you can do search list and filter list to look at metadata that you would like. And then the power supply here too as well. You can see here to the right here, the health is good roll up, the status is powered on, and the socket count is here. And of course, all your lifecycle buttons are here too as well for you to perform lifecycle management for this server. And those would typically be done by a server architect. So let's drill down into the actual server itself. And we look at additional information here. We've taken those particular buttons again and bolted them into this particular screen so that you don't have to backtrack and click on those buttons and perform the task. They're easily available for you here to perform them if you're in this screen. And then, of course, we have all the metadata here exposed within the server itself, such as physical asset information, we say, product family, SKU, motherboard type, serial number, form factor, manufacturer, BIOS version, BMC version, CPU count. It's an Intel-based processor, the memory size, and then also a RAID card of a SAS controller for NVMe. And then also power state is on and health rollup. So we see this here. The carousel view, if you want to look at, is a more high-level view of what we have in the server. You noticed here when I placed a mouse in the carousel view, it stopped scrolling. If I remove that in the carousel view, then at this point, it will continue to scroll. Moving to basically the navigation button here, we open up detailed information about essentially the server itself. And if we look here, you'll notice here there's local GPUs that are present here. And then here you can see here that we have GPUs here that are present. There's 8 of them. They're B200s and they're Gen 5. They have 16 lanes here and basically the serial number and firmware version. So you can see here that by opening up or collapsing and uncollapsing, we would see if there were any info ROM version, memory manufacturer, and memory part number. So this is typically a B200 Blackwell Compute. And you can see here other information that we provide here. All of this information here is basically system status and power, essentially, which is read through the out-of-band management of the BMC. So we're collecting all this metadata through Redfish as the source of truth being the BMC and providing that based on out-of-band. So bandwidth metrics, memory bandwidth metrics, so on and so forth. We provide that kind of information. You can look at DMI information here and also FRU information that's present. You can manipulate these particular FRU and DMI through our interface here. And then if there was an HBA present, which there isn't one, we would basically show there for any server that was using an HBA. And then also we have the GPU I showed you and NIC information. So NIC information is showing you here the AOC cards that are present in this particular server, and then we show the link state. And then also we show there's nothing here with iSCSI storage, but we want to look at local storage here. And we see here we have simple drives here of NVMe drives. We have quite a few of them in the list here in this particular server. And then also we can go ahead and blink basically that particular simple drive if needed, that maybe perhaps we sent personnel out into the data center to identify which particular drive was defective. And by turning on that drive, flashing that drive, the administrator or product engineer could or system engineer could replace that drive if it was failing. And then also we look at memory information. We have two NUMA regions here, NUMA region 1 and NUMA region 2, CPU 1 and CPU 2. We show information about the memory itself, the DIMM slot it is in, the part number, the size, device type, serial number, and manufacturer, and the health status of that particular DIMM. So if we wanted to look at CPU2, we could provide that information too of CPU2 that's installed in that NUMA region. And then if we wanted to look at processor, again, we could see this processor it's a 2-socket server, CPU1 and CPU2 with 2 CPUs, and the total core count is essentially 96 plus 96 for a total or 96 per CPU of total core. And again, we see here the carousel view information at the top, such as local storage information for NVMe drives and whether there was remote storage that was attached here.